Hi, I'm Steven Feuerstein, and I write practically perfect PLSQL.
Greetings and welcome to the PLSQL channel, a series of video trainings on the Oracle PLSQL language. My name is Steven Feuerstein, and I'm a PL/SQL developer just like you. This lesson is part of my series on effective management of PL/SQL applications, and the topic at hand is using data dictionary views to analyze PLSQL code. So, code analysis with data dictionary views. As I hope you're aware, one of the real big strengths of the Oracle RDBMS is that it's built on the SQL language, and also Oracle provides many different views that offer information about the contents of your database. And these data dictionary views can be accessed through the SQL language. And with these views, we can do, of course, many things, but in the context of PLSQL, we can analyze objects defined in the database. We can analyze source code for contents and patterns. We can analyze program unit structure and headers. We can check the compile time settings of our programs, and lots more. And with a good set of scripts, you can easily and productively analyze your code. So it's one thing to say, oh, I know about these views and I'm going to go out and do searches on them. It's another thing to have scripts available that you can use to do some really interesting analysis. Hopefully, the scripts that I show you today are at least the starting point for your own library of scripts. So what can you do? Well, let's start with the most basic, which is the all source data dictionary view, analyzing source code. So the all source view gives you access to all the source code of programs you own and programs you have execute authority on. So you can write queries against the source code to identify violations of coding standards. You can write programs or which programs contain and exclude particular strings. Now, all source is literally just your source code, so it's somewhat limited as to what kind of analysis you can run. That's where PL scope, which I'll be discussing in a separate lesson, comes in even handier because it looks at the structure and usages of the parts of your code. But this is a great starting point, and you can combine the contents of all source with other data dictionary views and utilities to give you additional information. For example, DBMesh utility format call stack returns the call stack, the execution call stack in your code, so it will tell you that A called B called C, and it will show you a line number, but it doesn't show you the actual source code, and you can do that. You can get that information by all source, from all source. Profiling information, when you run the profiler, it basically tells you which lines of code were executed, and you can combine that with all source to get the actual line of source code. And then this other view called all identifiers is at the heart of PL scope, and that analyzes all references to identifiers, which is even more powerful than doing source code analysis. And again, I'll be covering that in a separate lesson. So let's take a look at some examples. Starting off with the basics, let's take a look at the all source file. So here's a query that says get me all the source code for the program unit named parse, and I'm going to order by type and line. Now parse is a package. Let's go back to my data grid, sorry. Parse is a package. I said order by type, so it starts off with all my package code, and here's the individual lines of text. That's the actual same content that you'll find in the file containing the definition, which I'll show you in a moment. And after a while, we get to the package body. And literally, it's the same thing that you'll see in my parse package file. So I compile this program unit, and it shows up in all source. Now I can be a lot more selective than that. Here's an example of saying just show me the package body. So name is parse and type is package body. And then it's just the package body code. And then of course I could look for specific strings. So now what I want to do is find all the lines in my parse package that contain the word string. Run my script, look at the data, and here are all the lines that contain the word string, which are quite a lot given that it's a string parsing package. Again, this is fairly crude analysis. You can do much more sophisticated analysis using regular expressions, using Oracle context to do perhaps fuzzy logic analysis of the source code. But all that source code is there for you to look into. One additional example that I'll just throw in right now that I just thought of. One of my recommendations for standardizing the way you write code is to use a standard package format. So here's my template for my package creation with my standard header. And notice I've got this little text right here. So I could, assuming that this is the standard in my environment, that everybody has to use this standard header, I can easily add a query against all source, check for standard header usage, and it would look something like this. Let's take that query. We're not going to restrict by name, so we're just going to look at the currently connected schema, owner equals user. And I want to look for all the programs, select distinct name, where in string of my upper text does not look like standard header. So I'm looking for those programs that do not contain this line of code. So find all the programs that have this, actually let's just, where it's greater than 0, so it actually contains this. So upper text is like we're getting there. There we go. So this will now show all the programs, and it just shows the name once, that contain this string somewhere inside the program. Now obviously it doesn't mean that you're using it in the standard header, but unless somebody goes out of their way to modify the standard header or try to cheat and just stick this somewhere else in their code, even if they didn't use the standard header like right there, chances are this kind of query will in fact find all the programs that do follow the standard, and as a consequence from there you can find all the programs that don't use that standard header. So lots of different kinds of queries you can run against all source. The bottom line is that you've got access to all of that data. Let's take a look at the Val Standards Package. This is my attempt to write a rather simple utility to help you validate standards in your code. So in my package specification, I have a general program. Show me all the programs that are with the string. Show me all the programs that contain that string. And then I've got some higher level validate standards. Validate all of my standards for exception handling. Validate my standards for encapsulation compliance. We won't go into the encapsulation compliance right now. We'll take a look at exception handling. So the core program, show me the programs with this string. Find all the lines from user source where the upper text is like that string. So find me all the lines of all the programs that contain that line of text. And then my exception handling procedure says, show me all the programs that contain a call to raise application error, the exception init pragma, or the -20 string, which basically says ferret out all the -20,999 and so forth hard-coded error numbers for raise application error. And what I'm going to do here to just get a result faster is just add where row num is less than 25, because we don't want to really see all the code that's going to be coming back. So let's try it. I'm going to validate my exception handling. Whoops, I guess I just did something wrong there. Let's check. Compile. All right. And not where. And row num less than 25. Compile. Yay, it compiles. Let's run it again. And now I say validate standards, checking for presence of raise application error, and here are all the calls to raise application error. Checking for presence of exception init, there are my pragma exceptions init. Checking for -20. Now obviously, -20 can result in some other matches. That's why using a more sophisticated analysis, for example regular expressions, will probably give you better results. But the point is that once I set standards, like don't use raise application error in your application code, don't do pragma exception init except in a single consolidated error management package. Once I've set standards, I can use the all source data dictionary view to give me some idea of where those standards are being violated. Now PL scope and the all identifiers view will give you much more detailed information. We'll be covering that separately. Let's move on. Analyzing program unit and structure. So the source code is a handy source of information. As you can see, I can run various kinds of analysis against them. But it's also free-form text. It's just a bunch of text. You don't, for example, have the ability to easily parse that code and understand the meaning of the usages within them. So it would help if there was some more structured information available to us, and there is. There are at least two that are really very handy for PL SQL code. One is called all procedures, and that gives me information about every subprogram that I can execute. And unfortunately, it's missing some information, for example, the type of subprogram. I'll point this out in a moment. And then there's all arguments. All arguments gives me information about every argument of every subprogram that I can execute. It's an incredible amount of rich information. Unfortunately, it's not that well designed. It's hard to figure out some of these special magic values, and it's a rather interesting view. I've spent a lot of time with it and have gotten a lot of frustration from doing so, but I can also get a lot of information out. And by the way, you can also get a lot of the same information about the arguments of a procedure from the DBMS Describe built-in package. So all arguments and DBMS Describe each do roughly the same thing, and each of them have some drawbacks. I often use them in conjunction, one with the other, to get a full set of information about my program units. Let's take a look at some examples. So we'll start with a very basic all arguments script. So show me all the argument information for the specified package name. On my script, I'll do it for the parse package, and I see all the argument information, and there's a lot of it. So the object name is the subprogram inside the parse package. It's overloaded. There's the first overloading, here's the second, here's the third, and here's the different information. Subprogram ID, argument name, the position in the parameter list, the sequence, the data level. I'm not going to get into all the details of what all arguments is doing for you. It's actually very complicated and beyond the scope of what you're ever likely to want to do with all arguments. But notice the data type, whether or not it has a default value. That's very valuable. Though I believe the default value is actually always null. So even though it has a default value, all arguments doesn't record the default value. Too bad. The mode of the parameter, and so on. So that's a basic dump of all arguments. How could you use it? Well, let's say let's take a look at show procs with parmtypes.sql. So I've written a generic program here to select all the information from all arguments for the specified data type. For example, so let's compile this. And what I want to do is then find all the programs that contain a long data type. So with long. And here's one of them. Because longs are deprecated now, I should be using large objects, clobs or blobs or b-files. So what I want to do is show all the procedures that still use long as a data type in their parameter list. Run my code. Look at the results. So these 5 programs still reference or use long as an argument type, which means I should probably go there and do the conversion to using lobs. So just get all the rows from all arguments for that specified data type. And you might do the same thing for a fixed length string for car, another very potentially hazardous kind of data type. If I have a fixed length string parameter, that can cause some problems in terms of the code analysis or the way that the code is used for comparisons of the strings. And here are all the programs that have a fixed length string parameter, lots and lots of them. Whoops, that's longs. Where am I? Sorry, those are fixed length strings, but I forgot to change the header, I believe. Yeah, so that should be passing in the name of the type. That should be using the name of the type. So let's change that to type in. Do a little fixing of my code on the fly. Why not? Let's try it again. I'll recompile my program, run my analysis, and now you see all the programs that contain the fixed length data type. Okay, so that gives you some of a sense of what you can get out of all arguments. Let's take a look at all procedures. So all procedures gives me access to information about each individual subprogram. So let's take a look at show auth ID. Here's all procedures. The owner, the object name, the procedure name, that's the subprogram. It could be a procedure or a function. The overloading, is it an overloaded program? What's the overload number? Object type, aggregate, pipeline, and so on. Let's just take a look at the dump of the data. So obviously this is all procedures, so I'm going across all my data dictionary views. Let's actually change that to user procedures just for the point of view of looking at the data. So here's one of my procedure names. The type is procedure or package. Notice the object type is the name of the program, the type of the program unit as a whole, not the individual object. It doesn't actually tell me. One of the weird things about all procedures is it doesn't tell me if it's a procedure or a function. Is it an aggregate function? Is it a pipeline function? Can I execute it in parallel? Is it a deterministic function? What is its auth ID setting? So lots of information available. And I can then run queries against this data dictionary view to ask specific questions like, let's go back to all, get the auth ID setting of each of my program names, or subprograms actually. So I do this again, run this query again for the parse package, and I can see the auth ID settings of my program. I can also look at something that's actually determined or set on a that's set on a per program unit basis. Find me all the programs, all these subprograms that are deterministic. This applies to functions that can be used as in function-based indexes and also be called inside SQL statements and doing some caching of results. So this finds all the program units that are defined to be deterministic. Now, as I said before, one of the strange things about all procedures is that it gives me all the information about my subprograms, procedures, and functions, but it doesn't tell me if they're procedures or functions. You can see the word function here. That's because this is a schema level function. In fact, sorry, let's go back over to user procedures. So I've got packages, procedures, and so on. This is a schema level procedure, a top level procedure. This is a package. The package contains procedures and functions. This is a procedure. This is a procedure within this package, but it doesn't tell me if this is a procedure or a function. And oddly enough, I have to actually use the all arguments data dictionary view to figure that out. And if you ever need to do that, you can take a look at my is function. So is it a function? I pass in the owner of the package, the name of the package, and the subprogram name. And I can also pass the overload number if it's overloaded 15 times. The 12th overloading might be a procedure. The 13th overloading might be a function. So, and this is where you get into the tricky aspects of all arguments. But the bottom line is that in all arguments, the distinguishing characteristic of a function is that it has a return clause. And the return clause is a kind of parameter, but it doesn't have a position in the parameter list. So what I'm going to do is look for all the rows in the all arguments table that have a position of 0 and a data level of 0. And this means that there's an entry there for the return clause, which means that it must be a function. That's a pretty hard way to find out that information. It's unfortunate, but that's the way it is right now. They have not addressed this issue. All procedures does not include the actual type of the subprogram, procedure, or function. Moving on, let's take a look at compile time settings for program units. There's a view called All PL/SQL Object Settings that gives you information about the compile time settings of your program. So All Procedures gives you information about the actual definition of the program itself. Let's get back over there. So my user procedures or All Procedures gives me information about the static code itself. How is it defined? Is it an overloaded program? What's the overload number? Is it a pipelined program? Is it defined? What is the auth ID setting defined in the code itself? But PL/SQL Object Settings gives me information about the characteristics of the program unit at the compile time. What is its optimization level? Is it set to be optimized at level 2, 1, 0, 3? Is it compiled with native or interpreted? What are its debug settings? Compile time warnings, CC flags, check out conditional compilation if you're not familiar with that, and PL scope settings. Let's take a look. First of all, just a very general introduction to this view. That's the name of the view. I can say, well, select from it. And it gives me all these characteristics again because I asked for it all. It's showing me sys as well as everything else. Let's just change that to user to focus in a little bit more closely. So notice my procedure name. This is a top level, schema level procedure. Optimized at level 2, interpreted. Debug is not turned on. Warnings are disabled. Length semantics byte. Identifiers none. PL scope is turned off. There are no PL SQL CC flags. And I can find, for example, with this query, find me all the programs for which I have PL scope enabled. Identifiers all. Run this query. And I find that 23 program units have PL scope enabled. So again, you can write relatively simple queries against these data dictionary views to get information about your code. Let's look at something a bit more interesting. Let's take a look at what's not optimal and show non-default object settings. So this procedure, what's not optimal, passes in the level that you want to check for and finds all the program units in all PL SQL object settings that have a level less than the specified level. And then it displays that information. Of course, you could just do this in a query as well, but I'm addicted to PL SQL. So I run my script. And this shows me all the programs that have been compiled at an optimization level less than 2. Notice turned off entirely, set at a low level. These are all usually exempt from the consequence of running various demonstrations. In my production code, I always have it set to level 2 or higher. But this is a way of finding out all those program units that might cause problems in production. And this is the kind of query that you would run not so much in development or test, but in your production environment. After you've installed your application and all your code is compiled, make sure that nothing is set to an optimization level less than 2. And finally, show non-default object settings. A lot of us aren't that familiar with the PL SQL object settings and what the default value should be. So I put together this program to show me the object settings. And basically what I do is check, I retrieve all the rows for which the current value of that program unit is not equal to the default. Interpreted, debug turned off, warnings disabled, PL scope set to none, and so on. And with this program in place, I can then quickly identify those program units that have the non-default settings, which might be perfectly fine. There's nothing wrong with having warnings enabled, having PL scope turned on. But again, it's something that probably in production you'd want to make sure is nice and clean. We don't have warnings enabled in production. We don't have PL scope turned on, and so on. Conclusions. Well, I've shown you a number of data dictionary views that have to do with PL SQL code. There are certainly others, and even in the ones that I've shown you, there is much more that you can learn and do with those views. Hopefully I've given you a good starting point and a set of scripts to help you go exploring. But the bottom line is that you want to take full advantage of all the tools and data that Oracle offers you. You want to be able to fully understand your code, identify problems in your code, and again, I'm not here talking about compile errors. You'll find that out when you compile your code, but more analyzing the quality of the code. What have you written? What have other people written? Have they completely ignored the standards? Are they using old data types? And in fact, these views give you a way to validate that standards are being followed, that best practices are not being ignored. Data dictionary views give you a great way to access this information. Of course, you can use your IDEs. Many of them have code analysis tools built in or provide UIs on top of the data dictionary views. But it's also nice to complement those with your own data dictionary view scripts. Next steps. If you haven't already done so, download that demo zip. Try out all the various scripts that I've shown you. You might find that some of them are worth including in your own library or toolbox of code analysis scripts. And if you change them or find ways to improve them, don't hesitate to let me know. And of course, watch the other lessons in this series, making the most of the PL SQL compiler, code optimization, compile time warnings, conditional compilations, all of those referenced in the various views that I showed you in this lesson, and also PL scope. If you liked what you can do with these data dictionary views, you must check out PL scope and the all identifiers data dictionary view, which gives you a level of analysis that was never before possible and is new in Oracle 11g. And also check out my lesson on dependency analysis and invalidations of program units, and especially how to minimize those invalidations. Thanks for joining me. I hope this was useful, and happy PL SQL coding.